Hey, what's up? It's me. Hello, I'm Traga Pacer. Huh. Um, all right. I'm just gonna get straight into it because I don't think I'm gonna have many viewers because I'm just not gonna announce that I'm doing this week. Today. I'm trying something new where I don't try at all. Okay. Also, I'm gonna eat, so sorry also. Okay. So last week was Power over Ethernet. It was the end of auto negotiation and the start of Power over Ethernet. So I think I'm just going to start at the beginning of this chapter again. So here we go. Power over Ethernet, chapter 6. Power over Ethernet, or PoE, is an optional standard that provides direct current or DC electrical power over Ethernet twisted pair cabling. This makes it possible for an Ethernet switch port, for example, to provide both Ethernet data and the power needed to operate a low-power Ethernet device connected to the other end of the cable, such as a wireless access point. The system is carefully designed to provide both power and Ethernet data over the same cable without causing any interference with the data. Hey Javier, what's up? Welcome. It's PoE today. All right. PoE supports devices with relatively low power requirements, including wireless access points, voice over IP or VoIP, telephones, video cameras, and monitoring devices, making it possible to reduce costs by avoiding the need to provide a separate electrical circuit for the connected device. The power being provided is classed as safety extra low voltage, or SELV, SELV, I don't know how people pronounce it, which is defined as a voltage that's limited to a peak of 60 volts DC, provided by a power supply that has no direct connection to primary power or an AC grid, and which derives its power via a transformer or equivalent isolation device. Maybe I'll make a shit post on PoE. I think that would be cool. I made one in general on Ethernet not too long ago. And it was all right, but it was like very, very, very high level general overview. It's just when you get into the details of a technology at a certain point, it's very difficult to shitpost on it. It's very difficult to be like, this fucking thing does this, because it's not that simple. But we'll see. That's my challenge, right? That's what makes me a better network engineer, figuring out more creative ways to cuss out technologies. In other words, the power being provided over the Ethernet cable is carefully engineered so as not to present a shock hazard. The low voltages, electrical isolation from the AC grid, and limited current levels mean that the power being delivered is safe to work with, and that you don't need an electrician to install or manage these power circuits. All right, history lesson, here we go. PoE was first developed in 2003 as 802.3 AF, the supplement, which became clause 33 of the 802.3 standard. The original 802.3 AF version of PoE is the most widely deployed version of the standard, and it provides up to 15.4 watts of DC power for transmission over the Ethernet cable. Power over Ethernet is defined to work over 10 base T, 100 base T, and 1000 base T links. I'm just going to tell you right now, I don't have any like real world references in my brain for like wattage. So I don't know what the fuck 15.4 watt. You know what? Let me Google it. No one's shopping me. How much is 15.4 watts? Let's see what Google tells us. This is not helping me. Oh. Well, I found a cute little link that gives you what uses watts in your home. This website looks like it's from the early 2000s, so this tracks. What uses watts in your home? A bunch of stuff about calculating electrical usage I don't care about. All right, so we're talking 15.4 watts, right? At a maximum, I think. Yeah, up to the original. This is the original PoE standard, so 802.3 AF specifically, up to no more than, I guess, 15.4 watts of DC power. In comparison, what is the lowest I can find? Okay, so here's a few things in comparison. So like your dehumidifier, 257 watts. Your water heater, 4,500 watts. Your refrigerator, 14 cubic feet, roughly 440 watts. A bulb, a 60-watt bulb, guess how many watts that uses? 60. Let's see. Freezer is about the same as a fridge. Your range, an electric range, I guess, uses 12,200 watts. It's a lot of watts. Anyway, this is extremely low voltage, is what I'm learning here. All right, extremely low voltage. Okay. So, the current PoE standard doesn't specifically include or exclude 10 gigabase T-links. However, a call for interest was issued in March 2013 to propose an extension of the PoE standard that'll provide power over all 4 cable pairs simultaneously. Oh yeah, and we looked this up and it exists now. Based on the amount of work that needs to be done and the frequency of IEEE meetings, and assuming that work on the new specifications proceeds as expected, it's anticipated that the new standard may be completed by the spring of 2016. I'll remind you that this book was written and published, or the second edition of this book, which is what we're reading, it's from 2014. So at this point in time, they're talking about 2016, that's in the future. Now, I looked it up last time and it's like PoE++ or something is what it's called. It came out in like 2018. So yeah, anyway, so that exists now. It's PoE++. A revision of the PoE standard was developed in 2009 in the 802.3 AT supplement, which extends the Clause 33 specifications to provide up to 34.20 watts. That's still not very much because the lowest that I could find on that website of like wattages that things use was like the 60 watt, no, sorry, a 40 watt bulb. So that's not even up to like the lowest bulb wattage that I could find. What I should have Googled was wattage of common appliances, I think is better because it looks like there's some LED TVs that only use like 17 watts. No, I don't want to allow ads on your site. God damn it. Okay, whatever. I can see part of it. Yeah, okay, it's all LED TVs. Some of them use a lot of watts, some of them don't. Interesting. Anyway, still very low. So, why did there we go. A revision, yada, yada, yada. Okay, so we have PoE plus, we have PoE plus. So through 802.3 AF and then 802.3 AT. Then we got PoE plus plus, which I don't remember what that is. 802.3 something. And these nicknames may be seen in vendor marketing and documentation. Vendors have developed their own extensions to the standards as well to provide even more power. These include Cisco's Universal Power over Ethernet, which provides up to 60 watts, as well as the HG-base-T specifications developed by an alliance of consumer electronics vendors, which includes a power over HG-base-T component that can deliver up to 100 watts over 4 pairs of Cat 5e or 6 cabling. That'll be described later, apparently. All right, let's see. Goals of the IEEE PoE standard include power. We want to provide both power and data through the twisted pair cable. Literally the start and end, that is the point of PoE. Safety. Ensure that only safe or SELV, SELV, whatever, power is allowed onto the cable, which isolates the cable from any other power source. That's kind of interesting. Didn't know that. Yeah, I'm learning a lot about power today. PoE++, Mr. Digger Guy says, is 802.3 BT. Awesome. Thank you. Thank you very much. So they started with AF, then they went to AT, now they're at BT. I would like to hear the reasoning behind the letters that they use. Okay, so our purpose: power and data through the twisted pair cable. Safety, only safe power should be on the cable, so isolate it from anything else. Compatibility, it should work without modification over existing twisted pair Ethernet systems. Simplicity, we don't want to add any complexity for the end user beyond what's needed to connect the twisted pair Ethernet link. And it accomplishes that, right? Devices that may be powered over Ethernet. Access points, telephones, video cameras, lots of crap can be powered by PoE, which is awesome. And that's even just talking about the original PoE standard, AF, which provides roughly 15 watts. But, okay, they say in parentheses, the powered device may draw a maximum of 12.95 watts to allow for power losses over the cable. Okay. However, access points supporting newer 802.11 standards and containing multiple radios or video cameras that have motors for zoom, pan, and tilt functions can draw more than that. So the 802.3 AT revision of the PoE standard, or PoE Plus, provides up to 34.20. I don't know why they add the 0 at the end of it, but they do. 34.20 watts, resulting in a minimum of 25.50 watts at the powered device. Cool, 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 cool. Okay. Meanwhile, the widespread success of PoE has resulted in demands to support devices that have even higher power requirements, like display monitors, medical monitoring devices, and building automation systems like door locks, cart key systems, HVAC monitoring, etc. The adoption of light-emitting diodes for display monitors and general lighting has reduced power requirements for those devices, increasing the number of devices that could be powered by PoE if more wattage could be provided. Sorry, these fruit strips are really good. All right. As mentioned previously, to meet these increased demands, several vendors are already providing vendor-specific versions of 4-pair PoE that provide high power levels up to 60 watts or higher. These systems may not be interoperable. When the new IEEE standard is completed, so that is 802.3 BT PoE++, thanks again, Mr. Digger Guy, it will provide interoperable and vendor-neutral technology for achieving higher power over 4 cable pairs. Hooray, we've got it. All right, so let's talk about the benefits of PoE. I think we already have a pretty good grasp on it, to be honest, but maybe there's something else. PoE capability saves costs by avoiding the need for installation of power circuits for things like wireless access points, providing dedicated power circuits to hundreds or even thousands of APs located in buildings. In the ceilings of buildings across a campus network system would be super expensive. So obviously just powering them with the cable we already have to use to give it data is pretty damn good. PoE has been instrumental. Oh, this is a really good point. PoE has been instrumental in the adoption of 802.11 wireless LANs by making it possible to provide power and data over a single cable. This vastly simplifies installation and reduces the cost of an access point installation. With PoE, you can provide power anywhere there's an Ethernet cable, providing far more flexibility than would hardwired electrical outlets. PoE also improves remote management, monitoring, and troubleshooting PoE switches with management interfaces make it possible to provide manual power management of the powered devices. Using the switch management features, you can find out from the switch whether or not a powered device is drawing power and how much power it's using. You can also control power to a device such as an access point by sending management commands to the switch, making it possible to toggle power on and off as part of troubleshooting efforts. Which good point. Is this PDF provided by Real College? I graduated in 2006 and never learned those. No, I bought this. I'm probably going to get sued by O'Reilly at some point. This is a book that I bought. I'm sorry, O'Reilly, please don't sue me. Okay. The POE standard describes two device roles. So we have PSE and PD. PSE is power sourcing equipment. It's the device that provides power over a twisted pair Ethernet cable. So it provides the power. Makes sense, power sourcing equipment. It could be an Ethernet switchboard or an outboard power injector. I don't know what the fuck that is, but cool. The PD, or the powered device, is exactly that. It's the device that's being powered. So it's being powered by the PSE. A powered device could be a wireless AP, VoIP phone, IP security camera, something like that. It's also called, the power device can also be called data terminal equipment, or DTE, in the standard DTE. Okay. Is that a typo? Standard.DTE? That's just a weird, that sentence looks weird. The powered device is also called data terminal equipment, in parentheses DTE, in the standard DTE. I don't know. Well, you aren't distributing it for profit, so they'll probably only sue you a little bit. Yeah. Basically, yeah. I'm gonna keep doing it until someone tells me to stop. It's kind of my thing. I just read books out loud. I'm working on other things though. I'll eventually, I have an Ethernet PHY presentation projecty thing. It's really just my notes on Ethernet PHYs, but I've made them prettier and more presentable. And eventually, when I feel like I've learned enough-ish, I will want to talk about it instead of like just reading a book out loud on a stream. So at least there will be that. Anyway. Oh, a power injector. Okay, a device between a non-PoE switch and a PoE device. Oh, cool. Okay. A power injector is a small box you plug into the switch and power to provide power to the AP. It's used a lot in companies. Cool. That's good. That's good to know. Thank you. Thank you both. That's Mr. Digger Guy and Karome 007. Standard power sourcing equipment provides roughly 48 volts of direct current power to the powered device through two pairs of twisted pair cabling. So here's our little figure. Shows the two basic methods of sourcing power over Ethernet: Endpoint and Midspan. With an Endpoint PoE device, the power sourcing equipment is also the termination point of the Ethernet link, like a PoE switchboard. Okay, so that is Endpoint. So I guess that's this top one right up here. So we have our AC wall power that's plugged into the Ethernet switch, and then we have all our little PoE devices off of it, and that's it. Our Ethernet terminates at this switch. But then here we go. So there's no description here yet for this bottom part. Excuse me, but I assume that that is midspan. So let's see the difference here. Okay, that's exactly what y'all have been talking about, right? We've got an Ethernet switch, and in between that and its devices, we have the PoE power injector, PSE. Okay. So if the switch doesn't provide power over Ethernet, then you get that power injector, which we're calling, I guess, a midspan PSE. What does that stand for again? PSE stands for power sourcing equipment. Okay. So power sourcing equipment, midspan PSE. Makes sense because mid is in the middle. It's in the middle of things. Sphinx says, we use power injectors instead of PoE switches for almost everything we PoE. as we only have 1 to 2 PoE devices, which are 30 to 60 watts per device, so it's not cost effective to buy a full PoE switch to accommodate power. Okay, so it does make sense to me that a PoE switch would cost a bit more, but I wasn't sure about that. So I assume part of what you're saying is PoE switches are more expensive. Cool. All right, so despite the name, the power injector doesn't have to be located in the middle of the link. Instead, it can be located anywhere along the link that's both convenient and provides an AC power connection, which the Midspan PSE converts to DC power for injection into the Ethernet link. Okay. Okay. Cool. Taking a fruit strip break. Hang on. Wow. Midspan power injectors typically come in 2 forms: single and multi-port. Multi-port midspan power injectors provide power to multiple Ethernet devices. This device appears as a box that plugs into AC power, wall power, and converts the wall power into DC power for injection into the Ethernet link. Okay. That is, let's see, so the multi-port, multiple devices, single port, 1 device. Makes sense. You can also use the single port midspan injector, which plugs into AC wall power and provides DC power to a single device over an Ethernet link, like a wireless access point. Now, this figure shows a PoE splitter. This is a powered device that connects to a PoE port and splits out the DC power as a separate connection that's typically based on a round electrical plug that connects to an external device. Hang on. I'm struggling to see how this is different. This makes it possible to provide DC power and Ethernet data over the same cable to a non-PoE device. Oh, that has an Ethernet connection. Oh, okay. That makes sense. That's really cool. I didn't know you could do this. This is neat. So you can use PoE on non-PoE devices if you have this little port splitter. Or sorry, PoE splitter. Ha. They spelled it plitter. Look. I like finding typos. All right. The single port PoE plitter. Okay. Let's go back over what we learned real quick. This is all pretty new to me, so I'm just going to review it real quick. So our device roles, when it comes to PoE, we have PSE and PD. PSE, is the power source. What's powering the device on the other end? And the PD is the powered device that's being powered by the PSE. We can use an endpoint PSE, which is basically where our Ethernet cable terminates at the PSE, or we can use a midspan, which involves a power injector somewhere along the Ethernet line. So basically midspan would be if you don't, that's what you use if you don't have a PoE switch. Okay. But you want to power these PoE devices, right? Okay. So on the opposite hand, if we have a PoE switch, but we have a non-PoE device we want to power with that PoE switch, we can use a PoE splitter, or plitter as they have spelled it, which does the opposite. It just basically converts our PoE into the traditional separate Ethernet and power cables so that you can then plug it into the non-PoE device. Very cool. PoE type parameters. The original PoE standard was defined to provide 12.95 watts at the powered device over 100 meters of Category 3 or Cat 5 cable. The 802.3 AT extension provides 25.5 watts at the PD over Category 5 or better cabling. Cat 3 cabling is not supported at 802.3 AT or PoE+. PoE. Okay. To help organize the different specifications, the standard defines two types of power over Ethernet systems. We have type 1 and type 2 with different parameters for each. Type 1 refers to the original low power system, and type 2 refers to the newer system that provides higher power. Okay, so we have a table that's coming up showing the key parameters involved in type 1 and type 2 PoE systems. A power system is defined in the standard as a single PSE link segment and PD connected together. So PSE, then the link segment, then the PD. That is a power system. While type 1 operation works over old Cat3 cabling and adds no significant requirements to the cabling, type 2 operation requires Cat5 or better and a derating of the maximum ambient operating temperature for the cabling system. That was a lot of words in a row, so I'm going to read that again. Type 2 operation requires Cat5 or better cabling and a derating of the maximum ambient operating temperature for the cabling system. What is a derating of the maximum ambient operating temperature? The rest of it makes sense, but what does it mean if we're derating that? Is derating a word? I'm assuming that's not a typo. I don't know. Romad 007 says, you can use PoE switch on non-PoE devices anyway. Power splitter is a different thing. The network cable can have 8 bins. The power splitter is used to split the power and the data inside those bins. 8 bins. That's interesting. What does that mean? Like 8, just the cable having the eight different wires, essentially? I mean, that makes sense. Javier says, I used a PoE splitter to provide power in Ethernet to a Stratum 1 NTP server built around a Raspberry Pi when those boards came out. That's cool. That's cool. I love Raspberry Pis. They're so neat. All right. So we have this table. Let's see, what are we talking about? Okay, so basically what kind of maximum power we're providing, right? Power at the PD in type 1, we have 12.95 watts. Our maximum power that can be provided by the PSE is 15.4 watts. Voltage range 44 to 57 at the PSE. At the PD, the voltage range is a bit lower, 37 to 57. The maximum current is 350 milliamps. Is that milliamps? Because it's a small m? I don't know. And then the maximum cable loop resistance is 20 ohm, which means Cat 3 or Cat 5 or better. Okay. And it says, we have a little note at the bottom that says the power supply at the powered device will actually consume a small percentage of the available power, which is typically 10%, leaving the remainder for the powered device. So that's why I guess we get 12.95. They're taking that into account. So that's type 1. Type 2 is basically double type 1's wattage, 25.5 watts instead of nearly 13 watts. The maximum power provided by the power source with type 2 is 34.2 as opposed to 15.4 with the powered device in type 1. Voltage range at the PSE is 50 to 57. Voltage range at the PD would be 42.5 to 57. Our maximum current is 600 milliamps. Again, I'm assuming it's milliamps. And maximum cable loop resistance in type 2 is 12.5 ohms, which means we have to use Cat 5 or better. So that's stricter. Okay, so Chroma says 8 wires inside the cable. That makes sense. There's a max operating temperature for a given cable when carrying the max current for which it's rated. Resistance rises with temperature, and there are also considerations for the insulation. Derating means lowering the max operating temperature. But what does that mean in this context? So let's just change the word derating to lowering. what does it mean when we're saying it's required that you use Cat 5 or better cabling and you lower the maximum ambient operating temperature? Does that mean, what does that mean? Like, I don't know how to phrase like what doesn't make sense to me, but let's see, like, does it mean in practice when you're implementing this, you need to make sure to lower the ambient operating temperature for that cabling system? Or does it just mean like the Cat 5 cabling like inherently does that? You know, like how is it lowered? Where, in what way does it need to be lowered? Okay, so Javier is busy at work answering me. Thank you. The cable will start to warm up as you get close to the max current the cable is rated for. Okay, that makes sense. I'm gonna eat a fruit strip in the meantime. Um, hmm. Okay. I'm gonna keep reading, but Javier, when you come back, I don't want to rush you. Oh, here we go. So if the cable is starting to warm up in an already warm environment, then you could exceed the max operating temperature between the environment temperature and the rise in the cable temperature as the current flows through it. Okay, so that makes sense. So how do does this mean as I'm implementing this cable infrastructure, this cabling infrastructure, I need to make sure I have cooling going on, just like I would sort of plan a data center? Mm. I know you don't care, but these are really good. I'm not sponsored by them or anyone. Okay. Man, that would be the best way to get a sponsorship. Just send me snacks and I'll eat them in front of people while I talk about what I want to talk about, and then I'll show it on camera. Easy and very non-disruptive. Okay. Gonna keep going. Please feel free to jump in if you know more than me about this, which you almost guaranteed do. POE operation. The POE standard defines a method for powering a powered device over a cable by power sourcing equipment and then removing power when the PD is disconnected. Okay. The formal process includes an idle state and 3 operational states. First, detection, then classification, and then operation. The PSE leaves the cable unpowered, so it's in an idle state, while it periodically checks to determine if a PD has been connected to the cable. This process is called detection. Once a PD has been detected, the PSE may execute a probing process called classification to determine the current levels needed by the PD. If the PSE has enough power, then it begins the operation phase by powering the PD. It then monitors the power levels to ensure that the PD is still connected. Okay. Javier says, it means that even though the cable might be rated to carry X amps in Y degrees temp, you may need to limit the current to a fraction of X if the environment will be really warm. That's derating. Thanks. Thank you, Javier. Awesome. So as a reminder, I asked a question not too long ago about this sentence right here, where we're being told that type 2 operation of PoE requires that you use Cat 5 or better cabling and a derating of the maximum ambient operating temperature for the cabling system. Okay, so now I understand that that means, the derating part, I understand that that means that basically you have to consider the max ambient operating temperature actually lower as you're installing this. So like he said, I think Javier put it very well, you may need to actually limit that current, the maximum current, to a fraction of whatever it was originally rated for if you know that the environment's going to be warm. Cools. All right. So we have detection classification, and once a PD has been detected, the PSE may execute a probing process called classification to determine the current levels needed by the PD. If the PSE has enough power, it begins the operation phase by actually powering the PD, and then it monitors power levels to ensure that it's still connected. Easy peasy. Oh, okay, Javier says the cable datasheet might actually include a derating curve. That sounds like really nice because, I mean, what would you be doing? Like trying to do math to determine that, or just your best guess otherwise? Like, it makes sense. Be nice. Be nice to have a derating curve in the sheet somewhere. Cool. Thank you, Javier. That was very informative. Appreciate it. Okay, power detection. Okay, so it looks like we're going to go into these three like operational states of PoE. So we have detection. Several challenges exist when it comes to providing power over an Ethernet cable, with the first being, how do you know what's at the other end of the cable? If you just provide power without checking, you could damage any non-PoE equipment that might be attached to the end of the cable. After all, there's no guarantee that the twisted pair cable you're powering is connected to an Ethernet device. The cable might be connected to an analog telephone instead, which might be sensitive to power on its cable connection. If an installer tries one cable after another in an attempt to get something to work, which is not an uncommon approach, then a powered cable could cause a problem when connected to something that isn't an Ethernet device. Dun dun dun. To avoid placing power on the link, unless there's a powered device connected to the other end of that link, the standard provides a method called power detection for detecting the presence of a powered device. Once a powered stuttered a little bit there. Once a powered device is detected, then another set of mechanisms called power classification can be used to determine what power level is needed by the PD. Okay. Power detection is performed by the power sourcing equipment, which periodically monitors the Ethernet link for presence of a powered device at the other end. This is done by applying a small voltage, so we're talking 2.7 to 10.1 volts, to the cable pairs and measuring the current flow, looking for the presence of a 25,000 ohm resistance provided by the PD as a signal that it's present. A low voltage is used for detection because it's unlikely to cause damage to devices not designed for PoE that might be connected to the link. If a 25,000 ohm resistance is detected on the cable pairs, then this is considered a valid PD signature, indicating the presence of a powered device at the other end of the link. The next thing that the PSE does is determine how much power to send over the link. So that's classification. Hello, Doge Lord, welcome. Power classification. After the PD is detected, the PSE and PD can interact to determine how much power the PD requires. There are two power classification mechanisms that are used: physical layer classification and data link layer classification. All right, so layer 1 and 2. Type 2 PDs that require more than 13 watts must support data link layer classification, which is optional for all other devices. If both classification systems are supported by the PSE and the PD, then the information provided by the data link layer classification takes precedence over that from the physical layer classification. Okay, all of this is pretty straightforward, makes sense. Layer 2 over layer 1. Anything with a higher wattage has to support the layer 2 stuff. Makes sense. If a PSE has multiple ports, then the typical approach is to probe one port at a time, classify the power required, ramp up the power to the required amount, and move on to the next port until all the power that can be provided by the PSE is allocated. This makes it possible to bring up a port at the full power level supported for a Type 2 PD, for example, and then negotiate the actual power level needed by the PD using the data link layer classification system. Pretty cool. All right, the physical layer classification method. The physical layer classification was defined in the original 802.3 AF system, and all Type 1 PSEs may optionally use the physical layer classification system to classify the power requirements of the PD. If the Type 1 PSE doesn't support classification, then it simply provides the full power level of 15.4 watts whenever it detects a powered device. While that provides the simplest method of automatic PoE operation, most vendors use PSE controller chips that provide a power management capability to classify the power requirements on a link. The physical layer classification process occurs before a PSE provides power to the PD over the link. The process consists of the PSE applying a reduced voltage, which means between 15.5 volts and 20.5. Sorry, my voice now, of course, is starting to go. I have the weakest, larynx. The process consists of the PSE applying a reduced voltage, which means between 15.5 and 20.5 volts, into the cable pairs and measuring which one of a limited set of currents is being drawn by the powered device. The specific current detected is used as a signal provided by the PD to inform the PSE as to the current requirements of the PD. This makes it possible for the PSE to determine which of several current levels is required by the powered device before actually providing the full voltage and power levels to the link. After the classification process completes, there's a ramp-up process that increases the power to the level determined by the classification process. I should have brought water and I didn't. I didn't bring water. Okay, so we're basically just negotiating. This sounds very similar, honestly, to auto negotiation and everything else that involves talking over a link and negotiating something. Okay, so we have a table right here with the five power classifications defined in our standard. So if the Type 1 PSE does not support classification, then it must assign all PDs to class 0, which is 15.4 watts. Okay, but then we start at a lower wattage and move our way up. So 0 is just like the default. And so we're just going to assume the highest for that because that is the safest assumption. If we don't know, then we're just going to assume 15.4 because it can't be lower, if it's lower than that, we've got it covered, right? A Type 2 PD presents a signature that indicates it's a Class 4 device. A Type 1 PSE will treat a Type 2 PD as a Class 0 device and provide 15.4 watts if it has the power available. A Type 2 PSE will interact with a Type 2 PD such that both ends detect a Class 4 device. The PD will know that it's connected to a high-power PSE and may draw up to 25.5 watts. A Type 2 PD that doesn't receive the Class 4 physical layer signatures may choose not to start or must start at a power level of 13 watts and request more power via the data link layer classification system after starting up. Okay, so that's physical layer. Now we're talking data link layer. The 802.3 AT extension, so PoE Plus, defines a separate classification mechanism called data link layer classification that's based on LLDP. Transmitting LLDP packets with organizationally specific TLVs, where TLV stands for type length value. These packets are defined in clause 79 of the 802.3 standard. The LLDP packets, that's so funny that we use LLDP for PoE Plus. Okay, well, yeah, okay, for data link layer classification. The LLDP packets allow the network management functions supported by the PSE and PD to advertise and discover the power requirements of the powered device. The 802.3 AT extension defines LLDP information packets that can advertise this information between the PD and the PSE. Hey, Wookie Mitch. Chodesaurus, what's up? I can't believe you made me say that. ARP is life. Whatever. ARP is not always life, unfortunately. Um, The LLDP packets, I already read that. Type 2 devices are required to do both Type 1 physical layer classification and the data link layer classification. The Type 2 device will use the physical layer classification system to identify itself as a Class 4 device requiring high power. The Type 2 powered device must not draw more than 13 watts if it has not received a Type 2 Class 4 physical layer signal. Okay. All this is pretty straightforward. It's not too bad. Type 2 powered devices that can operate with less than 12.95 watts have to be able to be powered by a Type 1 PSE. If a Type 2 PD can't operate at less than that when connected to a Type 1, it has to indicate to the user that there's not sufficient power available over the link for the device to function properly. The LLDP packet exchanges also provide an optional capability to dynamically adjust power requirements after the initial detection and classification phases. Dynamically adjusting power can help manage the total amount of power that must be provided by a PoE switch on its Ethernet ports to meet the needs of the PDs, making the system more efficient. Sorry, excuse me. Note that the dynamic power changes are not designed for rapid variations. A PSE may take as much as 10 seconds to respond to a requested power change. Mutual identification. What is this? The interrogation and power classification functions make it possible for the PSE and PD to provide mutual identification, in which each determines whether it's connected to a Type 1 or Type 2 device. Mutual identification also provides useful information for devices that support power management features instead of purely automatic PoE. If a PD or PSE does not implement classification, it will not be able to complete a mutual identification process and will only be able to perform as a Type 1 device. Damn, I was going to try and get through PoE, but actually I see that now it is impossible because there are so many other sections on PoE. So, link power maintenance. Once the detection and classification processes have completed, then the PoE link is operational and the PSE is providing power over the link. The PD provides a maintain power signature, or MPS, consisting of both the current draw used by the PD and a specified input impedance, which can be sensed on the cable pairs by the PSE. This makes it possible for the PSE to monitor the link for the continued presence of an active PD. If loss of MPS is detected, then the PSE will quickly remove power from the link and return to the detection process of monitoring the link for the presence of a PD. All right, I'm sorry. My voice is giving out for some reason, like way earlier than it usually does. So I'm actually going to stop it there because I don't have water readily available. And yeah, my throat is just scratchy. So pray for me. Hope I don't have COVID. And I'll be back next week. Quick plug because I have to, but not because I have to, because I want to, but the logo back there that you see all lit up is the logo of the podcast of which I am a co-host. It's called The Art of Network Engineering, and we come out with episodes every Wednesday. We record on like Tuesdays and Thursdays, so I get mixed up. I'm pretty sure we release on Wednesday, but you can find it in your favorite podcatcher, so Apple Podcasts or Spotify or whatever. You should give it a listen if you're interested in network engineering or you're a network engineer and for some reason you haven't had enough network engineering in your life outside of work. Give us a listen. We talk to guests who have different roles in the network engineering world. Really cool people, every one of them. We also talk to SMEs. We talk about network design concepts. Yeah, we just talk about a lot of different shit and it's really cool. So you should check us out. Thanks for joining me. It's been fun. Sorry this one was a little shorter than usual, but I appreciate the patience. Thanks for teaching me things. Have a good one. I love you. Good night, etc.